Hi guys, today we're going to talk about solving by completing the square. When we are trying to solve by completing the square, our goal is to rewrite the equation so we have a perfect square on one side of the polynomial equation. Because those are pretty easy to solve. To get rid of the square, we just square root both sides. So we're going to go through two examples today. Solve by completing the square for 2x squared minus 13x plus 15 equals 0. We're going to follow 6 different steps. Our step 1 is going to be to move the constant. Right now our constant is 15, so we want to move 15 to the other side by subtracting by 15. Remember, I encourage you to show all your work, so hopefully we're minimizing our Algebra 1 mistakes. 2x squared minus 13x, and I'm going to leave a blank here because I'm going to be adding something to that side. And if I add something to one side, my addition property of equality says I have to add it to the other. So it'll be negative 15 plus blank on the right hand side. Our second thing that we're going to do is divide out the leading coefficient. We're going to divide out our leading coefficient because the goal is to write it in terms of x. There's not a number in front that we want to have there, otherwise it's going to make it a little bit more complicated for us. So our leading coefficient is 2. So division property of equality says if I divide by 2 on the left side, I have to divide by 2 on the right side as well. So we can simplify that. The 2's cross off. I've got x squared minus 13 over 2x plus blank equals negative 15 halves plus blank. So let's move on to step 3. Our step 3 says we're going to add b over 2 squared to both sides. That's what that blank was left for. So we are going to put in our b value, which is negative 13 over 2. We want to divide it by 2. So I'm going to copy the numerator, change division multiplication, and flip 2 over 1 to 1/2. So I've got negative 13 over 4, and now I want to square it because that's creating our constant in our perfect square trinomial. So we've got 169 over 16, and if I add it to one side, I need to add it to the other side. My fourth step is to factor into x minus b over 2 quantity squared. When I factor x squared minus 13 halves x plus 169 sixteenths, that factors into x minus 13 fourths quantity squared. And we're going to set that equal to whatever we get over here. So on the right-hand side of our equation, we need to get a common denominator. So I'm going to multiply by 8 to the numerator and denominator to get a common denominator of 16. So I have negative 120 over 16 plus 169 sixteenths. So we've got x minus 13 fourths quantity squared. And that's going to equal 49 sixteenths. And that looks very nice to me because both the numerator and denominator are perfect squares. Because our next step is to take the square root of both sides. So if I take the square root of the left-hand side, the square crosses off with the square root, and I need to take the square root of 49 sixteenths. So x minus 13 fourths equals positive and negative. The square root of 49 is 7, and the square root of 16 is 4. So I have positive and negative 7 fourths. Our sixth and final step is to solve for x. So we want to get x by itself. So I'm going to add 13/4 to both sides. So we have two different avenues for x. X can equal 13/4 plus 7/4, or x can equal 13/4 minus 7/4. So x equals 20/4, which leaves us with 5. And x equals 6/4, which is 3/2. So those are my two answers. Those are our roots, those are our solutions, those are our x-intercepts for our original equation. So x equals 3/2 and 5. So let's try that again, taking a look at another example. We know all our steps now. So move the constant to the right-hand side. So we're going to add the 3 to both sides. So 4x squared plus 6x. Leave a space for your new c. And addition property of equality, do the same to the other. Our leading coefficient is 4, so we're going to divide by 4. 0 divided by 4 would be 0. 0 divided by 4 would be 0 over there. And reduce. So x squared plus 3/2 x plus blank equals 3/4 plus blank. I want to take my b over 2 term. So here's my b. Dividing by 2 is the same as multiplying by the reciprocal, so 1/2. So b over 2 is 3/4. And then I want to square that and put it in the blanks. So 3 squared would give us 9. 4 squared, again, gives us 16. Do the same thing. Add 9/16 to both sides. So we want to factor the left-hand side, x squared plus 3/2x plus 9/16 to the quantity of x plus 3/4 quantity squared. And we have to get our common denominator again. So multiply by 4, and we're going to multiply the numerator by 4. So 12/16 plus 9/16. So the quantity of x plus 3/4 squared equals 21/16. So we can move on to step number 5, which tells us to take the square root of both sides. So the square root of the left-hand side cancels off the square. The square root of the right-hand side gives us two options. X plus 3/4 equals positive and negative. I want to split up my fraction, square root of 21 over 4. I cannot take the square root of 21, and it's already simplified as far as we can go. So I want to solve for x by subtracting by 3/4 to both sides. So subtract 3/4 and subtract 3/4. On the right-hand side, we have a common denominator, so I can write this as one fraction. X equals -3 plus or minus the square root of 21 over 4. And those are our two solutions. Those are our two roots, and those are our two x-intercepts.